Hi, hello. This is Dr. Jagadish Narendra Prasad, Senior Lecturer in Botany, Sri Chaitanya Goshala, Vijayawada. Today, we are going to discuss about enzymes, which is one of the topic under biomolecules chapter. We all know that most of the enzymes are proteins. Some enzymes, exceptionally, nucleic acids. The enzymes that are composed of nucleic acids called as ribozymes. So, ribozyme is an enzyme which is made with RNA, ribonucleic acid. If you take a proteinaceous enzyme, just like normal protein, the enzyme protein will also have a primary structure, secondary structure and tertiary structure. In the tertiary structure, the backbone of protein thread fold upon itself, crisscross upon itself, and forms a three-dimensional structure. As a result of this folding and refolding, you can see the formation of many three-dimensional clefts. These three-dimensional clefts or pockets are nothing but active sites. These three-dimensional clefts are nothing but active site. Many three-dimensional clefts are formed while protein thread backbone is folding and refolding, out of which some clefts or pockets acts as active sites. Active site, let us take this is an enzyme. Now this is active site. Active site is a region at which a substrate molecule binds to it. Now this is substrate. Substrate binds to the active site. When substrate binds to the active site with high rate of velocity, it carries the rate of reaction. And another important thing, enzymes are organic catalysts because they are proteins or they are nucleic acids. So, they are organic catalysts. They differ from inorganic catalyst in that inorganic catalyst remains stable even at high temperature and pressure. The inorganic catalyst remains stable. Whereas protein catalyst or enzyme catalyst get denatured when they get exposed to the around 40 degrees Celsius of temperature. Therefore, enzymes can be considered as thermolabile because they get denatured at 40 degrees Celsius, above 40 degrees Celsius of temperature. However, the enzymes of some organisms, say thermophilic organisms which live in hot vents or sulfur springs, the enzymes of such organisms remain stable even at high temperatures like 80 to 90 degrees Celsius. That means thermal stability is one of the important quality of such enzymes. So, they are thermostable. And when it comes to the chemical reactions, a reaction is two kinds. Physical reaction in which physical changes takes place and chemical reactions in which chemical changes takes place. A physical change is nothing but change in the shape or change in the state of matter. State of matter in the sense, say for example, water. Water can exist in the form of ice, vapor, liquid. These three are interchangeable depending upon the temperature variations. This is change in the state of matter. Whereas in physical changes, there is no bond breaking or making. Whereas in chemical changes, there is a bond breaking or bond making. These chemical changes are again two kinds. Inorganic chemical reactions, organic chemical reactions. One of the best example, BaOH taken twice plus H2SO4 gives rise to BaSO4 plus H2O. This is one example for inorganic chemical reaction. And hydrolysis of starch leading to the formation of glucose or any monosaccharide itself is called organic chemical reaction. That is the difference between these two. A rate of any chemical reaction, like which may be a physical or chemical, refers to amount of product formed per unit time. So, rate is equals to dou P by dou T. And this rate is called as velocity if the direction is specified. If the direction is specified, then it is called velocity. At the same time, among the various factors, temperature is one of the most important factors that influences the rate of a reaction more efficiently. There is a general rule of thumb that a change in temperature for every 10 degrees Celsius can cause doubling or getting half of the rate in either direction. So, any chemical reaction in the presence of a catalyst, the rate will be higher when compared to the uncatalyzed reaction. So, the catalyzed reactions rate will be higher in the presence of higher when compared to the uncatalyzed reaction. Let us take an example. CO2 plus H2O gives rise to H2CO3, carbonic acid. This reaction, in the absence of a catalyst, it leads to the production of only 200 molecules of H2CO3 in 1 hour. Whereas, in the presence of a catalyst called carbonic anhydrase, it is possible to get 6 lakhs of H2CO3 molecule just in 1 second. That means here the rate is get accelerated by 10 million times. That is the power of an enzyme. So, the power of an enzyme is extraordinary. That is very important. Now, another most important thing is that any metabolic pathway, a metabolic pathway is nothing but a multi-step reaction in which each step is catalyzed by an enzyme complex or a different enzyme itself is called a metabolic pathway. Let us take an example for metabolic pathway. C6H12O6 plus O2 gives rise to C3H4O3 plus H2O. Of course, this is a metabolic pathway in which now in this process 2 moles of pyruvic acid is produced from each glucose molecule. Of course, O2 is not involved. Now, this metabolic pathway is called as glycolysis. Glycolysis takes place in the absence of oxygen. So, in the glycolysis process, glucose get converted into 2 moles of pyruvic acid. With 1 or 2 additional steps, a variety of end products are produced. Say, for example, in skeletal muscles of human, we are going to get lactic acid as end product from this pyruvic acid. Whereas in yeast cells, we are going to get ethyl alcohol. Under aerobic condition, the same pyruvic acid is further oxidized and you are going to get carbon dioxide and water. That is the importance of these metabolic reactions. So, depending upon the conditions under which the reaction is taking place or whether oxygen is available or not available, depending upon all these aspects, different end products are produced from the same substrate with the help of different kinds of involvement of different kinds of enzymes. Now, in the previous reaction, we discussed that the power of enzyme is very efficient, like power of enzyme is extraordinary. Just we discussed that carbonic acid is produced in a large amount in the presence of enzyme carbonic acid, carbonic anhydrase enzyme. Whereas in the absence, very small amount of carbonic acid is produced. Now, here we have to understand how do enzymes bring about such high rates of chemical conversions. In order to understand this, we have to discuss first what is a reaction. Reaction is nothing but metabolic or chemical conversion. Here, a substrate is converted into product. So, simply to represent S plus E gives rise to P. So, here this is substrate and this is enzyme. In the presence of enzyme, substrate is get converted into product. Now, in this reaction, substrate has to bind with the enzyme. Substrate has to bind with the enzyme. Say this is an enzyme. Now, this is the substrate. Now, this is enzyme. The substrate has to bind with the enzyme. The substrate binds to the enzyme at its active site, which is a three-dimensional cleft or pocket. For this, substrate has to diffuse towards the enzyme. Binding of the substrate to the enzyme would lead to formation of ES complex. ES complex. This ES complex formation is a transient phenomena. Transient phenomena, which means it is a temporary phenomena. And ES complex formation is obligatory. During the binding of substrate to the enzyme, active site of the enzyme, there is formation of transition state structure. Now, this itself is transition state structure. Soon after this formation of transition state structure, bond breaking or making takes place in the substrate. As a result, the substrate is broken down into product. The substrate is broken down into product. This conversion of substrate into product must go through production of ES complex. I said this formation of ES complex is obligatory and it is a transient phenomena. Formation of ES complex is a transient phenomena. Now, the substrate is stable. Product is also a stable. Between the stable substrate and stable product, many altered structural states will be formed. This we have to be very careful and very carefully understand. Between stable substrate and stable product, there are many altered structural states are produced. Here, the word altered implies that all the intermediate states which are formed between stable substrate and stable product are unstable. So, here the stability is something related to energy status of a compound. A compound with higher energy will have less stability, and a compound with less energy will have more stability. Now, the substrate with low energy and product is also with low energy, whereas ES complex is in higher energy state. Now, let us discuss the same thing with the help of a graph. Now, this is substrate. The substrate is converted into product. In this graph, I am taking potential energy on the y-axis, progression of reaction or states through transition states on the x-axis. If you observe this graph, the substrate and product are located at different levels. Substrate is found at higher energy level than the product. Means product has lower energy. That means during the conversion of substrate into product, the energy present in the substrate got released. Therefore, the energy status of the product became less. Now this kind of reactions are called as exothermic or exergonic reactions. Whereas if product lies above to the level of substrate, then the reaction is called as endothermic. For exothermic reaction, there is no need of supplying energy. Whereas for endothermic reaction, it is essential to provide energy in the initial steps itself. Whereas for exothermic, there is no need of energy supplementation in the beginning. However, whether a reaction is exothermic or spontaneous or endothermic or energy requiring reaction, in all the types of reaction, substrate has to go through a higher energy level called transition state. It must go through a higher energy level. First, it has to reach a transition state, and then in the transition state, it gradually transforms into product. This energy difference found between substrate level and transition state itself is called activation energy. That itself is also called as Gibbs free energy. Now, the very important thing that we should remember here is the role of enzyme in this process is to reduce the activation energy required to bring the substrate molecules to the transition state. That is the importance of an enzyme's role. Look at this graph. In the absence of enzyme, the activation energy required for this substrate to become a product is more. Whereas in the presence of enzyme, it has been reduced. So that is the importance of the enzyme. So enzyme reduces activation energy required for the substrate molecule. And another important thing, during the process of reaction, the substrate and the enzyme, the substrate binds with the enzyme so that there is formation of ES complex. This ES complex then becomes EP complex, and finally enzyme and product are get released. So substrate is converted into product with the intermediate formation of ES complex and EP complex. This is what happens in the process of reaction. If you see different steps involved in the enzyme catalytic process, like if you observe the mechanism of enzyme action, there are 4 steps in this whole process. The step 1, first the substrate binds to the active site of the enzyme, fitting into the active site. Say if you think that this is enzyme and this is substrate, the substrate has to bind with the active site, fitting into the active site of the enzyme. This is what happens. This is step 1. In the step 2, binding of the substrate induces enzyme to alter its shape. This we have to be very careful. When substrate bind to the enzyme alter its shape as per the shape of the substrate and fitting more tightly around the substrate. This is what happens in the second step. In the third step, the bond breaking, now the active site of the enzyme, catalytic site of the enzyme is close proximity with the substrate. Therefore, bond breaking or making will take place. As a result of that, ES complex formation and EP complex formation takes place. In the fourth step, the product is released from the enzyme and the fresh enzyme is again ready to carry out another catalytic cycle. Like this whole process takes place in 4 steps. Let me show the same thing in the form of diagram. Take this is an enzyme. Now this is a substrate and now this is enzyme. Look at here, the active site and enzyme don't have the similar kind of shapes. The shape of substrate and active site is not same. Now substrate binds to the active site of the enzyme. When substrate binds to the active site, the enzyme alters its shape as per the shape of the substrate, and catalytic site of the enzyme now is close proximity with the enzyme substrate. Now this is catalytic site. The catalytic site is now in close proximity with the substrate. As a result, with the help of this catalytic site, The enzyme acts upon the substrate undergoes changes, thereby the substrate is converted into product. Once the product is formed, the product and substrate together called EP complex, and once EP complex formation is completed, the product releases from the enzyme and fresh enzyme is again ready to carry out one more catalytic cycle. This is what happens in the whole procedure. Now let us see the factors which affect the enzymatic activity. There are many factors which bring a change in the catalytic activity of the enzyme as they bring change in the three-dimensional structure of the protein. That includes temperature, pH, substrate concentration, and some chemicals which bind to the enzyme. If you take pH as one of the example, every enzyme will have an optimum pH at which they show optimum activity. Say this is the pH at which the enzyme is showing optimum activity. Any change in the pH can bring a change in the rate of reaction. If you reduce the pH, again the reaction rate decreases. If you increase also it decreases. Therefore, you are going to get a bell-shaped curve if you draw a graph for pH and enzyme. Similarly, for temperature also you will get the similar kind of curve. If you decrease the temperature from its optimum temperature, enzyme becomes temporarily inactive. Whereas if you increase the temperature, enzyme gets denatured at very high temperatures because enzyme is a protein. This is what happens with regard to the enzyme and pH. So even in the temperature and enzyme activity, you will get a bell-shaped curve. When it comes to the substrate concentration, if you increase the substrate concentration, the rate of reaction will also increases. Velocity of reaction also increases. If you go on increasing the substrate concentration, the rate of reaction reaches to the maximum. That itself is called as Vmax. If you further increase the substrate concentration, it does not increase the rate of reaction. Why? Because the number of enzyme molecules is lesser or fewer. Therefore, the rate remains stable once it reaches to the Vmax. So, substrate concentration is also having an influence in the enzymatic reaction. The substrate concentration which is required to cause half maximal reaction rate itself is called Michaelis-Menten constant. That itself is also called Km value. And enzymatic activity also depends on certain inhibitors or certain chemicals which shuts off the metabolic reaction or enzymatic activity. Such chemicals which shuts off the enzymatic activity are called inhibitors, and the process is called as inhibition. This inhibition is again three types. That is a competitive inhibition, non-competitive inhibition, allosteric inhibition. Here we are going to discuss about the competitive inhibition first. In case of competitive inhibition, the inhibitor, now this is substrate and this is inhibitor. The substrate and inhibitor resembling closely in their structure. There is a close resemblance of inhibitor in its structure to the substrate. Therefore, if the concentration of inhibitor become high, the inhibitor occupies the active site of the enzyme. When inhibitor occupies the active site of the enzyme, then substrate cannot bind to it. When substrate bind to the enzyme, so that the substrate is get transformed into product. This is what actually happens. Substrate binds to the active site, ES complex formation takes place, then EP complex, which is followed by the production of product, and enzyme is get released. Whereas, when inhibitor concentration become high, the inhibitor binds to the active site of the enzyme by competing with the substrate, because the substrate and inhibitor have close resemblance in their structure. Therefore, inhibitor will bind to the active site of the enzyme. When inhibitor binds, as a result, substrate cannot bind. This kind of phenomena itself is called competitive inhibition. This competitive inhibition is also having a very important role in medicine, that to control some of the pathogenic bacterial infections, we are using competitive inhibitors. So this is what you can see with regard to the competitive inhibition. And these are the various factors which influence the enzymatic activity. Now let us see classification of enzymes. Enzymes are classified into 6 classes, and each class is divided into 4 to 13 subclasses. And based on this classification, a 4-digit code is given to every enzyme. Every enzyme, a 4-digit code is given. Now, if you see the 6 classes of the enzyme, that includes oxidoreductases, transferases, hydrolysases, lyases, isomerases, ligases. These are the 6 classes. Oxidoreductases, these enzymes carry out oxidation and reduction. That oxidoreduction takes place between the 2 types of substrates. Say for example, S reduced plus S prime oxidized. Now after the reaction, S gets oxidized, S prime is reduced. So here S is oxidized, S prime is reduced. This kind of reactions itself are called oxidoreduction reactions, and enzymes are called oxidoreductases. Transferases, they involve in the transfer of groups other than hydrogen. Transfer of groups, say for example, Sg plus S prime gives rise to S prime G plus S. So here group is transferred from S to S prime. Between the 2 substrates, the group is get transferred. This is what happens in the transferases. Hydrolysases, they causes hydrolysis or breakdown of bonds in the presence of water. What kind of bonds? Like ester bond, ether bond, ester bond, ether bond, glycosidic bond, peptide bond, CC, C-halide, PN, such kind of bonds are broken down with the help of hydrolysases. Whereas lyases also causes breakdown of the bond, but without using water. So they causes removal of groups by reactions other than hydrolysis and leaving the hydrogen, double bonds. Say for example, CX and Y, CY is one substrate. Now XY is get removed and double bond is formed between C and C. This is one reaction which comes under lyases. Isomerases. Isomerization is nothing but it is intramolecular shift or interconversion of optical isomer into positional isomer or vice versa. So this kind of changes takes place in isomerases. Ligases causes linking together of 2 different compounds, linking together by using ATP. Say for example, it links, it forms a new bond between CO, CS, CN, PO. Such new bonds are produced with the help of ligases. So these are various kinds of enzymes which are classified into 6 classes, and each class is further divided into subclasses. There are 4 to 13 subclasses are there. So on the basis of this classification, every enzyme is given with a 4-digit code or 4-digit number. Cofactors is another important aspect under enzymes. Enzymes basically 2 types. Simple enzymes and hollow enzymes. Simple enzymes and hollow enzymes. The difference between simple and hollow enzyme is simple enzyme has only protein part. There is no non-proteinaceous part in the simple enzymes. Holoenzyme is one in which a non-protein part is also present along with the protein part. A non-protein part is also present. The protein part is called apoenzyme, whereas the non-protein part is called cofactor. The non-protein part is called cofactor. These cofactors basically three types: prosthetic groups, coenzymes, metal ion cofactors. Let us take first about prosthetic group. Prosthetic group is an organic cofactor which bind tightly with the apoenzyme of the enzyme. With apoenzyme, it binds tightly. That is the importance of prosthetic group. One of the best example for the enzyme peroxidase and catalase. Peroxidase and catalase, they causes breakdown of H2O2 into H2O plus O2. Here, either catalase or peroxidase required. This catalase and peroxidase need a prosthetic group called heme. The heme is get binded with the active site of this enzyme and it causes breakdown of H2O2 into H2O2. So this is one best example. Heme is required as a prosthetic group for the enzyme catalase or peroxidase. Next, coenzyme. Coenzyme is also an organic cofactor. It binds transiently with the apoenzyme of the enzyme. So what is apoenzyme here? Apoenzyme is nothing but proteinaceous part of the enzyme. It binds transiently with the apoenzyme of the enzyme. That too it binds during the catalysis process. The essential components required for the formation of these coenzymes is water-soluble vitamins. Let us take for example NAD, nicotinamide adenine dinucleotide, and NADP are some important examples for coenzymes. In the same way, metal ion cofactors are inorganic cofactors. They are not organic. They also bind tightly with the apoenzyme, whereas coenzymes bind loosely or transiently. Prosthetic group binds tightly. The metal ion cofactors, they bind with active site, like metal ion cofactor forms a coordination bond with the active site of the enzyme and also forms one or more coordination bonds with substrate. A coordination bond with active site, side chains of the active site, and also coordination bonds with one or more coordination bonds with substrate. So it is also binding little bit tightly with the apoenzyme part of the enzyme. One of the best example, Zn2 plus is a metal ion cofactor for carboxypeptidase enzyme. The most important aspect of these cofactors is if the cofactor is removed from the apoenzyme of the enzyme, the enzymatic activity gets shuts off. Like enzyme cannot carry out its activity. So this proves that the cofactor is very essential to carry out the enzymatic reaction or enzymatic activity. So this is what we can see with regard to the cofactors. This is about enzymes and other details of the enzyme, and we'll discuss remaining things in some other classes. Thank you.